One of the best ways to prepare for mathematical conversations with our students is by anticipating students' thinking. When we try to imagine what our students might say, we prime ourselves to better hear, understand, and respond to their ideas. Let's look at this image of an array where we ask how many squares are missing and anticipate some of the many ways students might think about and answer that question. First, it's worth noting that there are a couple of different types of strategies that students might use, the most common of which is to try to organize this empty region into something countable. You'll notice that the grid stops at the border of the empty space, and students may seek to extend this grid mentally in order to partition the space into units that they can count. And in doing so, they might count them one by one and arrive at an answer of 9 units that are missing. It's worth understanding that this kind of structuring of the space is complex cognitive work. It is called spatial structuring, and what might be obvious to us as adults is anything but to young children. Create space for students to try to work on this and to discuss what the units actually are. Some students may not be able to easily see this grid in the empty space and to impose structure on it, and will benefit from opportunities to practice. Some students will count one by one, but others may seek to chunk that unit into smaller pieces like pairs of squares that they can see. Here we see 4 pairs for a total of 8 squares, with one up at the top that's unaccounted for a total of 9. Some students may notice a square here and call that 4 units, and then think of the bottom as either 4 or again 2 and 2 with one more at the top. Students may decompose them into columns and focus instead on these pieces 3, 4, 1, and 1. This is difficult work, and some students may seek to avoid trying to decompose that empty space by noticing the structure of the entire array. This array is a 5 by 6 array. It has a total of 30 units in it. Now, some of those units are missing, and students might decide to figure out what's missing by counting what they can see. They might decompose this orange region in a variety of ways. For instance, they might notice this rectangle here that's 3 by 4 and know that it's 12 units, with another 3 up here, a loose one down here, and an entire row of 5, and compose these pieces back together to find out that there are 21 orange squares. If there should be 30 total and 21 are orange, they might simply subtract to realize that 9 are missing. In this way, this activity can be about subtraction, it can be about composing number, and it can also be about decomposing two-dimensional space. We encourage you to try one of these array missing questions with your students today.